We are building a novel dataset for ray tracing benchmarks using data extraction from modern video games. When you open any research paper dealing with ray tracing, you may find a selection of traditional models used for the benchmarking. These include objects like Stanford Bunny, Happy Buddha, Dragon, Erato, and others. There are also objects like Hairball that focus on stress testing against triangle edge cases. However, object-centric scenes are not ideal representatives of typical ray tracing workloads, as most rays escape the scene after the first hit. Buildings and architecture models like Šibenik, San Miguel, Amazon Lumberyard Bistro, and others are also widely used but lack spatial extent, spanning only a few tens of meters. There are larger models such as Power Plant, Ranghold, and others, but they lack the level of detail hierarchy typical of video games and other ray tracing workloads. Some production-ready scenes are available, such as Moana Island and Activision Caldera. However, datasets like these are very uncommon. Open-source projects such as Godot Engine or Blender also provide some demo assets, which could be usable. However, there is another possible source of benchmarking data: modern ray-traced video games. What you see now is an interactive view of the ray tracing acceleration data structure used in Cyberpunk 2077 as visualized in NVIDIA Inside Graphics. You can observe the massive spatial extent of the scene, as well as increasing level of detail as we move closer to the ground. Recent years have witnessed a shift towards ray tracing in video games, and the number of ray-traced games keeps growing. Production-ready scenes from these games of such a scale and detail are a culmination of hundreds of person-years of artistic labor, and using them for benchmarking purposes in research would be a great help. Unfortunately, no existing frame capture software, proprietary or open source, supports exporting the geometry of the captured ray tracing acceleration structures. We are building our own solution that targets ray-traced games using DirectX 12 graphics API running on Windows. Our command line tool injects a payload into a game process, hooks API calls of interest, and tracks the state of acceleration structures and the underlying geometry resources. The tool is reasonably performant, maintaining an interactive frame rate of the game and not leaking any memory, which was somewhat challenging to achieve. When pressing a key shortcut, the game freezes for a while, outputting all the active acceleration data structures to disk. DirectX 12 uses a two-level acceleration structure hierarchy, and all the geometry used in ray tracing is embedded in these data structures. While the ray tracing rendering pipeline and corresponding graphics API calls are quite elegant and simplistic, there are many technical challenges involved to achieve this result. We describe them in detail in the paper. Once the export is done, the game can continue without issues. We can parse the exported data to produce an actual model. The preliminary result you see right now is roughly 7% of all the geometry of the scene. While we successfully capture all the data used in the acceleration structures, we now only interpret a subset of the data with a specific triangle type in a specific format. The initial results show our approach is feasible, but the hardest problem is yet to come. We plan to ask rights holders, the game companies, to grant us explicit permission to release the captured datasets. There are many issues related to licensing, artistic intellectual properties, and other concerns, so we'll see how it goes. Even if we do not secure the permissions, we hope the work remains relevant and beneficial. Thank you for listening.